Here we have an application example, and we will use this function we just defined for the multiplication of a matrix with polynomials. So let's take our signal and filter as in our SymPy example, but we will write them as polynomials of vectors x equal to 5, 6, 7, 8, 9, 10 with n equals 3, and its polyphase representation then is this 5, 6, 7 plus z to the power of minus 1, 8, 9, 10. Similar for our filter, we have this impulse response, and then the polyphase representation will be 5, 4, 3 plus z to the power of minus 1, 8, 7, 6. So these are polynomials whose coefficients are vectors. In Python, we simply store the sequence of vectors with the exponent as index in the third dimension. So this is what we are doing here. The exponents are on the third dimension for 0, for z to the power of minus 1. And then we are multiplying these two. And what we have is 70, 230, 187. And if we look back, is 7, 230, 187. And this is what we have here. Observe that this result in the time domain corresponds indeed to the one with SymPy in the z domain.